Hello. In this video, we're going to go ahead and look at the graphs of inverse functions. Two functions are inverses of each other if their graphs are symmetric about the line y equals x. So what we want to do on example 2, or on this example, is to graph y equals x on each grid. Then determine whether each pair of functions graphed are inverses. Okay, first let's go ahead and graph y equals x. So to graph y equals x, notice that y equals x is a line. It is a line where the slope is 1 and your y-intercept is 0. So it would start at the origin, go up 1, right 1, and it just keeps going, or down 1, left 1. And then you can just connect all of those with a trusty straight edge. There you go. That is the line y equals x. Now here's the thing, we want to determine whether each pair of functions graphed are inverses. Going back up here, it says two functions are inverses of each other if their graphs are symmetric about the line y equals x. So looking at this, now what does it mean to be symmetrical? It means that if you fold it, the graph, there we go. If you fold the graph along the line y equals x, the left-hand side has to equal the right-hand side, or the one side has to be the same as the other. In other words, that's saying that if there's a point here, reflecting this, there has to be a point here. Notice that if you fold this, that's where this would be. But notice that that point is not on this line here. Therefore, no. These two functions are not inverses of each other. Now let's look at letter B here. Graphing this, the line y equals x. Fantastic. Notice that if you fold, the purple will become the blue, and the blue will become the purple. So if you fold it along y equals x there. So this is in fact a set of one-to-one functions. Now, we need probably a slightly better way of determining this. I already kind of showed you what happened over here, but let's make it a little bit more formal. This point here that was on the blue curve was the coordinate -1. And what we mean by symmetric about the line y equals x is if you replace the x with y and the y with x, you should have a point on the other curve. In other words, if you switch this x and this y, the coordinate that you get from that would be 0, -1. And that's where this is. But notice that that point is not on this purple curve. Therefore, no, these are not. But let me show you what they would have looked like had we looked at inverse functions. So 0, 1 here, 0, -1. Notice over here we also have a coordinate that passes through here, and that coordinate is -2, -1. Flip those around, makes that -1, -2. So go left 1, down 2, there's another point right there. And notice that there's another point on the curve here. That coordinate is 1, 2, 3, 4, 5, 1, 2. That'd be -5, -2. So flip the x and y makes that -2, -5, which means there would be a point here. So the function would look like that. At least the inverse function would. Next, let's look at the purple curve here. Notice that there is a point here at the coordinate 1, 0. Flip those around, that's 0, 1, and there would be a point there. At the coordinate here of 2, -1, flip that around, makes that -1, 2, makes that a point there. And of course, 5, -2 here. Flip that around, makes that -2, +5, and that makes a point up here. So, connecting those with a curve would look like that. Notice that this is the inverse of this, and this is the inverse of this. So the two blue functions are inverses of each other, and the purple functions are inverses of each other. But the blue and the purple are not inverses of each other. Now let's look over here. The same thing is happening, so let's kind of see what's happening. Origin 0, 0 stays the same. Then they happen at they both happen to be -1, -1. That's fine. Nothing changes. Now, notice that there looks like there's a point here at 1, 2, 3, 4, 1, 2, so -4, -2. Flip those around, -2, -4, means there would need to be a point there, and yes, there is. Now, another thing that is interesting is in order to have inverse functions of each other, if one function ever touches the y equals x line, the other function has to also touch the y equals x line. So notice that they both started at the origin and they both crossed at -1, -1. Okay, in other words, when the x coordinate is the same as the y coordinate for either function, in order to be a one-to-one function, the other function also has to be at that exact same point. Alrighty. Well, I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.